Hello, this is the luckiest maths teacher in the world, and today we're going to look at trigonometric equations. They're going to be equations like this. So say 2 cos x plus 1 equals, let's say, minus a half, or something like that. So what makes this a trigonometric equation is, of course, the cos in here, but it could also have a sine or a tan. And because of the presence of that, we need to treat them a little bit differently than how we would treat an ordinary linear equation. But we do start off by treating it like a linear equation and getting all numbers to one side. And when we've done that, because we want to get x by itself, as we do with any equation, we want to get x equals blah, 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 we'll end up needing to use the sine inverse, cos inverse, or tan inverse, and we can do that on our calculator. And so far that's, pretty easy. That's similar to what you would already know. But what makes these a little complicated is that there are quite a number of solutions. And we know that from our last lesson on the unit circle. We know, for example, that if cos theta equals a half, there are two solutions to that. So we need to use our knowledge of the unit circle to find all solutions. And I'll show you how to do that. So let's actually go ahead and do this equation in blue. 2 cos x plus 1 equals minus a half. So firstly, we're going to treat it like a linear equation. We're going to get all the numbers over to one side. And remember, the way we do that is by reversing the order of BODMAS. So the first thing I'm going to do is actually minus 1 from each side. So I get 2 times cos of x equals, so negative a half minus 1 gives me minus 3 over 2. And then what we're going to do is divide each side by 2. And we get cos x equals negative 3 over 4. So this equation here and this equation here are equivalent equations. We've just made it look a little simpler. So you can get one solution by finding the cos inverse of negative 3 over 4. But that won't give us all the solutions. Now, I hope you know that when we have cos x equals something, we can't just divide by cos because it's not an actual number. Now, I know that this is probably going to sound weird, but I don't want you to put cos inverse of negative 3 over 4 on your calculator. What I want you to put on your calculator is cos inverse of positive 3 over 4. Now, the reason for that is if we find the cos inverse of positive 3 over 4, we will be able to find the cos inverse of negative 3 over 4 really easily using our knowledge of the unit circle. If we put cos inverse of negative 3 over 4 on our calculators, the problem is it'll give us one solution, but that'll make it a little bit hard to find the other solution. So I'm telling you to do it this way because I think that that'll make it easy. Because when you put cos inverse of a positive number like 3 over 4, your calculator will give you the answer between 0 and 90 degrees. So let's go ahead and put that on our calculator. So when I put that on my calculator, cos inverse of 3 over 4, I get approximately 41.4 degrees. So make sure your calculator is in degrees, not in radians, because then you'll get a totally different answer. So that's not actually the solution for x to this equation, but it allows us to find the other solution. So the way we're going to do that is by drawing up the unit circle. So remember, the unit circle is a circle in the Cartesian plane, and it has a radius of 1. This is what we went through last lesson. If you never watched that video, perhaps you'd like to go and watch it. So what I'm saying is that the cos inverse of 3 over 4 is 41.4 degrees. So if I were to draw a triangle like this, remember cos gives us the x value, so that means that along here, radius 1, this value here is 3 over 4 or 0.75. That's the length there. So that means that to make a triangle like this angle in here would have to be 41.4 degrees. Now, this allows us to find what the cos inverse of negative 3 over 4 would be, because as we discussed last time, all are positive. So when I say all, I mean sine, cos, and tan are all positive in the first quadrant, then it's only sine, only tan, and only cos. So all students take calculus. So what I need to do to find the cos inverse of negative 3/4 is I need to draw a triangle that's congruent to the blue triangle I just drew. And because it's congruent, this angle here will be the same. It will be 41.4 degrees. But of course, what that means is, because we said in the previous video on the unit circle that we take the angle made with the positive x-axis, it means that this angle here will be 180 minus 41.4. So that angle in green is 180 minus 41.4, and that is approximately 138.6. So the angle in green is 138.6. So what that means is a solution to this equation, x equals 138.6. So your calculator may have given that, but then it wouldn't be easy to find the other solution. We know there's another solution. So again, I want to find a value of x that makes cos x equal negative 3/4. So I found the one in this quadrant because cos is negative here, but it's also negative in this quadrant. So I'm going to draw a congruent triangle in this quadrant, the third quadrant, because I know that cos is negative there. So if I draw a triangle here, the blue triangle should be congruent to the other two congruent triangles. And again, this angle that I'm going to mark in black and call theta, this angle here must also be 41.4. So the angle made with the positive x-axis will be the angle all the way around. So the angle in yellow is going to be, so it's 180 from here all the way to here, and then we add another 41.4. So 180 plus 41.4 gives us 221.4 degrees. So these are the only two solutions, and I know that because cos is positive in the other two quadrants that I didn't try. I didn't find the solution here or here. I don't need to, because I know I can't get cos x equals negative 3/4 because cos is always positive in those quadrants. So I found the only two solutions between 0 and 360 degrees. If I add any multiple of 360 to these solutions, they will also give me a solution to the equation. So if I take 138.6, and I add 360, I get 498.6, so that will also be a solution. But I'm only going to worry in this video about solutions between 0 and 360 degrees. Now, just to point out, solution has the same meaning as it has done in any previous equation we've gone through. When I say solution to this equation here, I mean a value I can substitute for x to make the statement true. So if I say substitute this value for x, if I put in my calculator 2 times cos of 221.4, and then I add 1 to my answer, I will get negative 1/2. I will get a true statement. So I'm going to do one more example using the same steps, and I'm going to do it a little quicker, so please copy this down if you need. So let's say I've got the equation here, 3 sine x minus 1 equals 1. I want to find a value that I can substitute for x to make the statement true. So again, I start off like a normal linear equation, add 1 to both sides, I get 3 sine x equals 2. Now I'm going to divide each side of the equation by 3 because I want to get the sine x by itself. So I get sine x equals 2/3. Now, what I'm going to put in my calculator is I'm going to put sine inverse of 2/3. Now, 2/3 is positive, so I can just put that straight in my calculator. So the answer I got to that from my calculator, just putting in my calculator, is that x is approximately 41.81 degrees. So I have solved the equation, but then that's not all of the solutions. So again, I'm going to draw my unit circle. I'll do it a bit bigger this time. So again, it's a circle with radius 1, and it's in the Cartesian plane. So I've just found out that if I draw a triangle like this, and I make this angle here 41.81, the sine of that angle is going to be 2/3. Another way to say that is that the y value of the point where this line meets the circle is going to be 2/3. It's going to be some x value and 2/3. So I want to find another value that makes this true. I want to find another value for x where sine x equals 2/3. And remember, to do that, I'm going to draw a congruent triangle. Sorry about my drawings. They're not great, but these two triangles are supposed to be congruent. So if they're congruent, then this angle in here is also 41.81 degrees. So because they're congruent, this distance here will be the same, so the y-coordinate will be positive 2/3. Because I know, from all students take calculus, I know that sine is positive in the second quadrant. So my other solution is going to be in the second quadrant because sine is also positive here. But remember, the second answer here is not 41.81 because we're interested in the angle made with the positive x-axis. So I'm actually interested in this angle here. The sine of this green angle will give me 2/3 as well. So it is 180 degrees from here all the way around. So the green angle is the 180 degree angle minus the 41.81 degree angle. So my other solution is going to be 180 minus 41.81. And that gives me about 138.19 degrees. So these are my only two solutions between 0 and 360. I can't find any solutions in this quadrant because sine x won't be positive, it'll be negative. And I can't find a solution here because sine x will be negative, it will not be positive. So these are my only two solutions between 0 and 360. So again, if I substitute any of these solutions, this one or this one, if I substitute them for x into this equation, it will become true. So I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.